Hi everyone and welcome back to my channel. In this video we'll be looking at ER modeling. ER modeling is used to mean entity relationship modeling in SQL and database management systems. So ER modeling is useful for conceptual design of a database management system. Every organization uses ER modeling in many ways to, you know, document their ontologies, their agreed set of concepts about their businesses, and a lot of other organizations also use it as a clean technology independent mechanism for designing their databases. Now, there are many different types of graphical representations of ER system, and there are many helpful tools to help us um, design our database. In this video, we'll be using just as you can see on my screen, this is called erdplus.com. So that's what we'll be using, erdplus.com. I'll be putting the link in the description below. It's a free tool that you can use to design your database, conceptually. So let's talk a little bit about entities. I started by saying that this video is about entity relationship, right? Design. So let's talk a little bit about what entities are really. So when you think about entities, I'd need you to think about a table, right? Basically, we've been manipulating tables a lot in this playlist. So when you think about entities, think about basically a table. So an entity represents a noun or things that an organization cares about, things that can be represented on a table. They can be physical, they can be logical. They usually have like a primary key, and they are just things that can be identified independently. And like I said, it corresponds to a table in a relational database. So there's this other term that's sometimes used, interchangeably with the term entities. It's called entity sets. Now, entity sets represents the type or class of nouns, or like I said, tables, while an entity itself represents a specific instance of that type. For example, we could have a table, right, that contains uh, data about many employees, right, and their attributes. So that's an entity set. But one instance of it would be called an entity, if that makes sense to you. Okay. So in the course of SQL videos, we have been able to manipulate different kinds of data. We looked at our spy data, we've done our online shopping data, and all of that. So, um, with all of the experiences we have gathered in, manipulating all these data, I would need you to kind of like conceptualize them well, we talk about this. If you remember, we talked about primary keys, which, are unique identifiers for a given table. And we also talked about foreign keys and all that. So the first thing I'd like to talk about is when it comes to relationships, right? There are different kinds of relationship. We have one-to-one relationships, we have one-to-many relationships, we have many-to-many relationships. And in this video, I'll also be showing you how you can show what kind of relationship your entities share. Also, this is like a blank canvas. So for every entity, would be representing it with a rectangle. The attributes will be represented with like an oval shape connected to those rectangles, and the relationship between entities or tables, as the case may be, would be represented with a kind of, call it a rhombus, right? It looks more like a rhombus to me, or a slanted rectangle, as the case may be. So before we take our first example, I want to talk about one more thing, and that's what we call a weak entity. So an entity or a relationship, let's say a weak relationship. A relationship is weak when it's used to show inheritance. That is, the relationship is connected to another table. So that means if that other table were to be deleted, that table that it's connected to via a weak relationship would also be deleted. For example, if you remember in our online shop data set, we had a table for so many aspects of our businesses, including order, right? For like when you order something. And then we had another table for other items. Now, if you really understood that table, you would realize that the other items table depended on the other table. So that means that there was a relationship between the order table and the other items table, but because the other items table is dependent on the other table, the other items table had like a weak relationship. There was like a weak relationship going on there. So if we ever deleted the other table, then that means that the other items table would also be deleted because then it's no longer connected to anything, if that makes sense. So let's take our very first example. So our first example, we'll be looking at our author's table. A book, we did also have a book data set that contained author's table, the publisher's table, and all of these tables. I would also put down the link to these data sets in the description below, just in case you are, looking at this video for the very first time and haven't seen the rest. So the very first thing we are going to try right now is to create a conceptual model for the concept of a book. And let's say that this book has a unique ID, which is the primary key, and other attributes like title, page count, and genre. So, like I said, the very first thing when you want to create an so this is an entity. It's usually like a rectangular shape. So this is like a regular entity and we want to call this entity. If you can see my screen, once you click entity, you have that rectangular shape and then you can edit it, attach the name, what kind of entity it is. I talked a little bit about weak entities. So, but this is not a weak entity. So this entity will be called book because I said, just repeating the question, I wanted us to create a conceptual model, that is an ER diagram, right, for the concept of a book. And this book has some attributes like a unique ID, it has a title, it has page count, and it has genre. So the name of this entity will be called book. So that means that this book did in our database there would be a table called book, if that makes sense. Okay, so now let's add attributes. The first attribute we want to add is that unique ID. It has a unique ID and it's unique. That is the primary key. So whenever you see like an attribute that's been underlined, I want you to think about it like a primary key. Then I want to add another. So this, let's call it the title. So right now my screen is on dark mode because I find that through all of you's feedback that it's better for videos. But if I switched it up a little, and I think I'll just do that for a minute just so that you see that there are lines connecting the entity to its attributes. So let's put that off for a minute. So this is it. I'm sorry if that hurts your eye, but I just needed you to see that we have lines connecting the entities to the attributes. I think I'm just going to leave that on because uh, it helps our experience for this video. So yeah, coming back to this, we said we also had page count, and we had the last one. You can move this around. Um, we also had a genre. hmm So that's it. That's it. So this is what a conceptual design of a books table might look like. So this shows that there is a table called books that has all of these attributes. When I mean attributes, when I say attributes, I mean columns. So it has a column for genre, page count, title, unique ID, and this being underlined means that unique ID is its primary key. So let's take another example. Let's say we have, I can move this around a little bit. Let's say we have another entity still in that same database, right? And it's going to be called author. So let's put it down here, author, and we can edit that. This entity is called author, and we want to add some attributes to it. So let's say that this author's table also has a unique ID called author ID. It has attributes, age, and name. So let's get that here. We have author ID, and it's unique. So I'm going to click unique, and I'm going to add other attributes like it has name as well. And down here it has what else? It has age. Every author has an age. So at this point, what you see on my screen is a conceptual design of a database that has two tables. The first table is called author with all of these attributes, and the second table book with 4 attributes. So let's say that these tables are connected in a way. Um, let's say, so in this third stage of this design, we want to create a third conceptual model that shows that the book entity is connected to the author entity with a relationship set named write. So basically what we are saying is that authors write books, right? And I think that makes sense. So let's add that. So that would be relationship. Relationship, this is it. So what is our relationship? The relationship is going to be called rights because authors write books, right? And remember, just before we start talking about this example, I said there are many kinds of relationship. There is one to one, there is one to many, there is many to many. So think about it. Um, the relationship between the author and the book is that an author writes book. So an author can write many books, right? But for each, an author can write one book, and one book can be written by an author. Does that make sense? So let's take it again. An author can write many books. An author can write many books. So that's like one to many. So let's do that. Entity one, which is what? What's an entity one? Author. An author can write. An author can write many books. Yeah, so this is what we were going for. An author can write many books. So one author can write many books. So that's like one to many. So let's so we have we have one author writes many books. So as you can see on my screen, entity one author, just like I said, many book one. So what we have showed right now is that w- we have just shown a one to many relationship. One author can write many books. Also, we can show an additional relationship, and that, let's say we want to say that a book is written by one author. So we can come here and we click on mandatory. So a book, an author must write one book. That's just what we've said. And of course it's true. You must be able to write one book to at least be called an author. So a book must be written by one author. So this is the relationship we have on the screen right now. So I'm just going to reiterate. An author can write many books. So these three in one line, that's the many. So one author can write many books, and one book, a book must be written, or an author must write one book as well. So we have a one-to-one relationship and a one-to-many relationship as well. Okay, so let's take another example. Um, let's take another example. Let's design another conceptual model for a club. Let's use a club, and that club has a name, it has an office location, and it has a phone number. So let's just get started with that. Can I move this up a little bit? Yep. So let's create another entity. We say we want to create a club, and the club has, like I said, it has a name. Is the name of a club unique? I don't think so. So it has a name, it has office location, office location, and it has a phone number. Okay, this is phone number, and it has a phone number. So in this case, that let's assume that the name of our club is unique. So let's assume that it's a primary key. So we just said that, and that the club is usually and that a club is usually defined by its name. So let's imagine that, for example, if we said Manchester, everybody knows, Manchester. So let's assume that that club is the club's name is unique and it's usually defined by its name. And let's also say that a club has only one location, and a location has only one club, if that makes sense. So let me say that again. Let us say that a club has only one location, and a location has only one club. Interesting. So how do we show that a club has only one location? So would that be an entity, or would that be a relationship? So it sounds, because a location only has one club, that could be a relationship because the location does not have any other attributes. So let's create that relationship between a club and a location. So let's say let's write that out here. A club has only location, and every location has one club. So um so what is this identifying? It's identifying a club, right? We want to say that a club has one location. What is this identifying? A club as well. Okay, so we want to say that it has um a club has one location, and every location has one club. So it's one and mandatory. It's just like saying if and only if. Okay, so a club has only one location, and a location has one club. So that means, if you think about this more carefully. This would mean that if a club has only one location and every location has only one club in it, it means that that location, there should be like a weak attribute connected to that location, which is office location as well. Because if you think about it, if a club has, if my club can only be in a certain place, let's say in Manchester, right? And Manchester only gets to have only my club. So it means that we could tie the office location column to this. It's just going to be weak. So let's do that. Let's tie attribute. Would have an attribute here. Mm, It's going to be a derived attribute. So because it's dependent on the club attribute. Let's call that office location. It's also unique. Um, so I'm just having to do this. So office location. All right. So let's keep going. So let us also say that clubs sponsor events, and each event has one main sponsor and possibly has co-sponsors. So that means we have an event table that has a relationship with a club, and that relationship is going to be called sponsor. So a club sponsors events. I hope that you can you can be able to figure out what's an entity, what's a relationship by just listening to yourself saying the sentence as they come. So every club sponsors an event. So that means there is another entity going to be called event, and let's call that event. It's going to be regular, and I want to add attributes to this, but before we add attributes, we said that clubs sponsor events. So our relationship is going to be sponsor. And yeah, so we said every club, let me just take that again, just so that we can put in our relationships where they belong. We said a club, clubs sponsor events. So that's many to many. Clubs sponsor events. If you heard yourself say that, clubs sponsors events. So that's um, many to many, right? And each event has one main sponsor. So that means one club can sponsor one event. So let's take that again. Each event has one main sponsor and possibly has co-sponsors. So one event can have one club or one club sponsor it or not. So that's it. It's optional. If you can see me, click that. So let me take that again. The second condition is that each event has one main sponsor and possibly has co-sponsors. So each event has one sponsor or more. So that's why this is the optional, right? It has one main sponsor or more. So that's, if you see the sign here, that's what this means. It's like w- each event, each event has, this event has one main sponsor, is sponsored by one club or more clubs. So that goes, this was at many, this was here. Yeah. So that goes there. So let me just interpret this again. So clubs, many clubs, the first condition is that clubs sponsors clubs sponsor events, so that's many to many. This 3 into 1, many to many. And the second condition is that each event has one naming sponsor and possibly has co-sponsors. So that means one club or more can sponsor an event. So you have this little oval sign here. It says an event can be sponsored by one or more sponsors. Anyway, so let's move on. So an event has attributes like title, the title of the event. So we have title, and we have dates. We have another one, dates, date. We have another one, location, location. We have another one, and description for the event. So let me put this, yeah. So and each event is uniquely defined by its title and date. So it means that the event doesn't have like a unique identifier, but if you combine the title and the date, you get like a unique identifier. So that's composite. That's what it's called, composite. So this is it. So we have our second conceptual design. I hope that the relationship then is clear to you. Like I said, many clubs sponsor many events. So that's clubs sponsor events. So that's many to many. But an event can be sponsored by one club or many clubs. So that's an event has a main sponsor and possibly co-sponsors. So that's that also says that events can be sponsored by one club or more. So that's why this optional sign is here. And but the thing is, for an event to hold, one club must sponsor it. They may be co-sponsors. So anyway, I'm thinking we should look at um one more table, then we can end this video. So let's do a new ER diagram. No, no. Okay, so in our last example, we want to identify a scenario that would be best modeled with a weak entity. Interesting. So let's imagine a scenario that will be best modeled with a weak entity and an identifying relationship. So we want to explain the scenario in English, then we design a conceptual model for it. So let's see how we can go about that one. I'm trying to renew this page. What is this? Okay, great. I just refreshed the page. So anyway, if you wanted any of these diagrams on this website, erodplus.com, you just have to click here and then export. But I didn't really want any of those, so I just refreshed. So let's think about a scenario that would show a weak entity relationship. So think about this. The scenario in a hospital, the doctor and the patient. So the doctor treats the patient, and there could be another table called the visit table. And because the patient gets to visit the doctor, the visit table exists, if that makes sense. So let's think about it for a moment. So we have the concepts of a doctor and a patient, and the doctor has the unique, it's their unique ID. Anyway, names, specialization, and can treat multiple patients. So let's put that down. I like to put down what I think as they come because putting them down helps me get it more correctly. So we have the doctor, and we said he has like a unique ID, which is his identifier, and he has or she has um a name. The doctor has a name, and she has a specialization. Maybe her doctor is a heart surgeon. She has a specialization and can treat multiple patients. So let's undo this guy. Yeah. Okay. Specialization. I mistakenly deleted the first one. So if they treat patients, and let's say the patient has unique ID, name, age, illness, then that's under table. So it means that now we have a patient entity. So we have patient that has some attributes like name. I think a patient should have a name. They should also have like a patient ID. Let's call that PID, which is unique. Mm, I like the sound of PID. So let's call the doctor's unique ID DID. I think that sounds nice. Anyways, so we have, what else would our patient have? So let's say our patient has an age. Oh my god, I just get to delete things mistakenly. I did just deleted PID, which is unique. Okay. So let's see again. Our patient has name, age, PID, and an illness, whatever is wrong with them. So an illness, and there's supposed to be a relationship here because we said that the doctor treats our patient. So that relationship, let's call it treats. Treats. And let's think about this. So let's establish the relationship that we have here. We can say that doctors treat multiple patients. So let's say treats, yeah. So let's say doctor treats, a doctor can treat, a doctor can treat many patients, right? A doctor can treat many patients, but a doctor also, so a doctor can treat many patients, and a patient can be treated by one doctor. It depends. So I think we should just go this for the both sides. So a doctor treats, many doctors treat patients. So that's like many to many. But as a doctor, you need to treat one patient to be called a doctor, and a patient also has to get um treatment from at least one doctor to be called a patient. So that's just what we have put down here. And remember, the whole point of this scenario is because we are looking for like a weak entity. So let's say that while our doctor and patients are all strong entities, we would have another entity called visit. That's like another table. But the visit table only exists because there is a doctor and there is a patient. So let's call that visit, and it's going to be weak. Remember, we said that the weak entity or a weak relationship is weak because they depend on some other thing. So they are weak because what they have because of inheritance. So if I ever delete the doctor table, then there'd be no visit table because who would the patient visit? if I delete the patient's table, then there'll be no visit table because who would visit the doctor? I hope that makes sense. So, so now we have a visit table that is weak. Let's add an attribute to it. So, what should the visit table have? I think that it should have the DID. Come on. I think that it should have the DID, which is the doctor's unique ID. I think that it should also have um it should also have the PID, which is the patient's ID, and I think it should also have dates because every visit has a date. So what can make this unique though? What can make this visit table unique? Now, because a doctor could have treated all of the patients, and a patient could have received treatment from all of the doctors. So it means that if you ask me, I think that a combination of all of these three should make up a unique ID for a visit. So for me to be able to identify the visit you're talking about, you should be able to tell me what the doctor, the patient, and the date. So let's call these a composite, right? Let's go back here. Let's call it a composite. And the relationship is, let's call it attends. That's the relationship. So there's a relationship between visits and patients, and there's a relationship between doctors and visits. And this is because somebody is attending to somebody, right? Let's call it attends. Um, so what are we going to say? So when you click on identifying, it kind of gives it that double that shows it is weak. So we can say one visit. You can have one visit at a time, right? So we have patients and a visit, and we have patient has patient attends one visit, and there'd be one visit at a time. And let's get over to here. It's going to be the same relationship. So this is doctor, this is one, this is visit, this is one as well. So there you go. This is what it looks like. I hope that this example is very clear. Um, we're going to end this video here. I think that we've done such a good work talking about conceptual design. There's still so much more to be discussed though, but if you got everything we talked about in this video up to this point, you are off to a very good start. So I'll see you in the next video. If you liked this video, remember to like the video, actually subscribe and comment. I'll see you in the next one.